Electron affinity. Okay, so we abbreviate this EA. That's the energy change when a neutral atom in the gas state gains an electron. So it's kind of like the opposite of an ionization energy. Neutral atom gains an electron. Sometimes this is negative, exothermic. Sometimes it's positive. Some atoms really don't want another electron. And so it's going to be positive because you're forcing them to take an electron that they don't want. So some of the alkaline earth metals, all the noble gases, have a positive electron affinity. Why would a noble gas want an additional electron? It wouldn't. They are perfect as they are, right? Don't add anything to me. Don't take anything away either, right? Just leave me alone. Technically, if you're talking about electron affinity and it's positive, then it's not really an affinity anymore, is it? So a lot of times we'll just say, well, it's greater than 0, so we'll just lump them all together. You can't really measure it because it's not really an affinity anymore. The trends in electron affinity suck. It's just not very good at all. About the only decent trend is in group 1A. As you go down, electron affinity decreases. It becomes less negative, more positive. Because larger atom, more shielding farther away, less attraction to the nucleus. Okay? The other groups don't really show a good trend. Very generally, electron affinity becomes more negative as you go across a period, but again, not really great. Highest electron affinity in any period is a halogen. The halogens, chlorine, fluorine, bromine, those guys make -1 ions, right? So you can kind of think, well, yeah, they'd probably be pretty happy about getting a negative electron. So those are the trends. It's really not very good. We see that this goes down, and that's about it. These guys are all greater than 0 because you have to force them. There's no affinity for the electron. And these guys are the highest. Properties of metals and nonmetals. You should be familiar with these. Metals are malleable and ductile. So those are two words that you might not be familiar with. Malleable means that you can pound it into a flat sheet. It doesn't work with things like rubber or glass, right, or carbon. If you pound metal, it dents, right? And if you keep pounding at it, it'll flatten out eventually. That's a unique property of metals. Nonmetals are brittle. They're going to shatter and break into pieces. Metals don't do that. Glass is actually a more of a compound. But yeah, it's definitely not a metal. Ductile means that you can draw it into a wire. So you can heat it and pull it in a certain way, and you can pull it into a wire. You can't do that with nonmetals. Metals tend to be shiny, lustrous. They reflect light. I mean, think about a metal thing versus a nonmetal thing. You know, a plastic coin versus a metal coin, right? Nonmetals are generally dull, non-reflective. There are exceptions. Metals tend to conduct heat and conduct electricity. Many nonmetals are insulators. Metals make oxides, and most of them are basic, and they are ionic compounds. Nonmetals form acidic oxides, and they're molecular compounds. Metals form cations in solution. Nonmetals form anions and polyatomic anions. Metals lose electrons in reactions. They become oxidized. Nonmetals gain electrons. They become reduced. So they are aptly named. Here are the metals, and here are the ones that are not those, the opposites. So metallic character is how much like a metal is this element. So it could be, I mean, if you think about men and women, right, and there's stereotypical ideas of femininity and masculinity, right? And just because you are a female doesn't mean that you're necessarily very feminine according to those, you know, societal guidelines or whatever, right? So you can say, well, this woman is more feminine or this one's less feminine. This is the same idea here. whether it's a metal or not, you can say that it's more like a metal or less like a metal. So we see that metallic character decreases from left to right, and it increases down a column. Now this one is absolutely the simplest one. So how do you do this? So there's a stair-step line on the periodic table, right? I always forget exactly where it starts. It starts right here. So there's the stair-step line that separates the metals from the nonmetals, right? The ones over here are metals, and the ones over here are not. So if you go across metal, 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 semi-metal, non-metal, 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 oh, metallic character is decreasing as I go that way, right? If I pick this row and I start up here, non-metal, non-metal, semi-metal, semi-metal, metal, oh, metallic character is increasing as I go down. And that trend applies to the rest of the periodic table. Okay, so that one you can just kind of figure out.
Under what conditions can mercury be a solid metal?
Mercury will be solid at a lower temperature. It just has a low freezing point. So metallic character, again, increases as you go down, because here's the nonmetals, and then we get into the metals. And going across, it increases. I'm sorry, decreases, because these are nonmetals. Let's do one of these. Germanium or tin. You got to find them on the periodic table. So here's germanium. There's tin. Which is more like a metal? Tin. And if you look at it, germanium is actually a semi-metal. So the rest of them, I don't feel like doing that. My head hurts. You can figure it out. That one's